And now let's move on to how you're going to use statistics in your research. You won't actually do statistics because you're not going to collect any data or give your survey to any participants. But you need to plan which statistics you would do if you were to actually conduct this study. So let's dig into talking about variable types and helping you figure out which statistical test you would need for your specific study because it's going to be different for some of y'all. So let's start with scales of measurement. There are different features that things that we can count in our studies can have to them. So variables can have categories, they can have ranking ability, something is higher or lower than something else. We can have equal distance between intervals or not, and we can also have a true zero or not. So let's look at the different data types and which features of these they have. Examples of variables like gender, where you could code it as a number, 1 equals female, 2 equals male, or 0 equals male, 1 equals female. The number doesn't matter. License plate numbers, that's another variable you could write down, but which number it is doesn't actually matter. They're just different from each other. They're in categories. Race or ethnicity could be represented as a number similar to how we talked about gender. And the number on a jersey is just an identifier as well. It is a category, and we call this nominal data because the numbers are just names or categories. They could just as easily be represented with a word as they are with a number. They're not numbers that we can do any real math with. That wouldn't make sense. And anytime when I'm helping you decide which statistics you need to do, I refer to these as categorical variables. So if you used gender as a predictor variable or your like quasi-independent variable, subject variable, whatever, as something that you think influences something else, then you have a categorical predictor variable or a categorical IV. We have other variables that you can rank. So they have categories that can be put into names like bachelor's degree or PhD, but you can rank those. A PhD is a higher level of education than a master's degree, which is higher than a bachelor's degree, which is higher than an associate's, which is higher than a high school diploma or a GED equivalent. So education level is one of those variables where we can have words that are categories. Are if we assign a number to each one, like 1 was didn't finish high school, 2 was high school or GED, for example, those would be categories, but this has something extra that nominal data doesn't have. It can be ranked. One of these absolutely means more of something than one of the others if it's a higher number. These are also, though, categorical variables. So if I say categorical variables, if you're trying to determine which analysis to do, if you're trying to determine which statistics you should write about in your analytic strategy section, you need to know whether your independent variable is categorical or continuous. This is another type of categorical data. Other examples of ordinal data include things like if you're just rating attractiveness between people, you could rank people, but the distance from the highest to the second highest attractive person may be different than the distance between any two other people in attractiveness. So the distance between the levels that you can rank is not always going to be the same here. Tax brackets are the same, where they're pretty wide. So just because I, for example, am in a higher tax bracket than one of my friends, or another one of my friends is in a higher tax bracket than me, the distance between our incomes might be different because the tax brackets are pretty wide. So the distance between people in tax brackets is not going to be the same for every person or the same between one bracket to the next. Now, not all of y'all might have been paying taxes for very long, so maybe that's not quite as relatable an example. So generations is another one. So you can rank this data. Boomers are definitely older than millennials, who are older than Generation Z. But both of those are younger than Generation X, right? The distance between a given person who's a millennial and a given person who's a boomer is not always going to be the same. So I'm a millennial. My dad is in Generation X, but I know other people who are still in Generation X who are way younger, right? And the distance from me to them is not going to be the same as the distance between me and my dad if we're looking at age. So the intervals between a person who's in each of these generation categories is not always going to be the same. We can rank them though. Another type of data is one where we do have numbers as categories. They can be ranked, but they have equal distances between those intervals so that each person in one of those categories the distance between them to the next one is going to be the same as the distance between anybody in category 1 to category 2, or the distance between category 2 to category 3, etc., is going to be the same as from 1 to 2. One example of this is temperature. A degree is always the same length. So a difference of 1 degree is always a difference of the same amount of movement in molecules, which is what we measure when we measure temperature. Personality traits in psychology are often measured in an interval fashion, which is what we call this type of data, where they are categories, they can be ranked, but most things on a Likert scale from a 1 to whatever, if it does not have a true 0, it's going to be interval data. And what I mean by true 0 is the 0 means you actually have none of that thing at all. So a 0 for temperature doesn't make sense in terms of 0 doesn't mean no temperature, right? No temperature will be 0 movement of molecules at all. Absolute 0 on the Kelvin scale of temperature is a true 0, but that's something that we can't even achieve. Like nothing on Earth is at absolute 0. That's so incredibly cold. So like 0 Celsius is freezing for water, 0 Fahrenheit is just kind of an arbitrary number. Neither of those mean 0 temperature. There's no such thing as having no temperature. Personality traits and attitudes are similarly measured in that way in psychology. You're not going to have 0 of introversion. You might just have lower levels of introversion compared to another person. Measuring something like attachment is going to be similar too. You're not going to be 0 attached to anybody, but you may have a different profile of attachment to people that you're close to, and that could be measured on a 1 to 7 scale or whatever, right? So the features of interval data are that they are categories, they can be ranked, they have equal distance between points, but there's no true 0. We do call these data continuous variables. So if you have interval data, you can consider that a continuous variable when we look at trying to decide which stats you would say you're going to do. And if you have interval data, let's say you have a questionnaire that's full of interval data, like I gave you a personality questionnaire with 20 questions, you could add all of them up to get a total personality score if you were interested in that. If you asked 10 different questions about extroversion, you could add all 10 of them up and get a sum, and that's a single score for extroversion. So that's how you would handle interval data. Instead of taking an average, you can add it up and then use that sum in your analyses. Now, again, you're not going to be doing these analyses, but just planning them. You need a single number for each variable that you would plug into your analyses, like a single column of data in a spreadsheet. And we're also going to look at this in spreadsheet format. So if you have a bunch of questionnaire questions that are asking about the same thing, if they're all interval data on the same scale, all on 1 to 7, and the 1 to 7 means the same thing in words, you can add up a person's answers to all of those, and you would have a single anxiety score or whatever else it is that you want to measure. Ratio data is very similar to interval data. The only difference is we do have a true 0. One example of this might be measuring amounts of different symptoms that you have, whether psychological or medical. So you could have a true 0 that means I don't have this symptom at all, but you could have like a 1 to 7 that's varying degrees to how intense you have that symptom. Age is another example of ratio data. Hours of sleep is ratio data. You can have a true 0 of I pulled an all-nighter. Calories consumed, you could have a true 0 of a fasting day. These data do have categories. They can be ranked. They have equal distance between points, and they have a true 0, which makes them ratio data. And if you have multiple questions about the same idea, like multiple depression questions, but you want a single depression score for your analysis, if depression is your independent variable, for example, you would need to average together all your depression items, and that could give you, if your depression items were ratio data, where a true 0 means I don't have this symptom at all, you would average together these items to get a single score to use for your analyses. And this is another type of continuous data. Hey folks, I wanted to give you some quick real-world examples of data that I've actually collected to show you these data types. So I'm going to share my screen to get started. So I've got just an abbreviated set of variables from a very large data set where I gave people a survey with a few hundred questions. The first data type I want to show you is the kind where our number doesn't actually mean a number you can do math with, okay? This is a number that's just standing in to represent a category. And we could have just as easily put a word there and it would mean the same thing. So here I have this variable named sub ID, and you can see there's numbers, integer numbers. And what that is to protect our research participants' privacy. I didn't collect their name or anything, so I need to be able to tell one participant from the other, so I just assigned them all a participant number. I just went down through the line of what order these responses came in on my survey and assigned them a number 1 through whatever. Let's see how many we actually have. 1 through 149. And you can see there's a few missing because we deleted those participants from the survey. So that's why the numbers don't always line up with the row number there. But this number wouldn't make sense for us to like take an average of it or subtract anything to it or add anything to it, right? It's about as meaningful as a jersey number. It's just a category, and we call it nominal, which means name, really. So this number might as well be a name. That's why we call it nominal. We also call these variables categorical, and I tend to use that language a lot more because that's what we did in some of my graduate stat classes. So when I say categorical variables, that's what I'm talking about, these nominal categories that aren't like real numbers, right? We stuck a number there, but it's a placeholder. Another type of nominal measurement here is the way I measured gender. Now, I left this one as an open-ended item, and so people typed in their identities themselves instead of me giving them a list to choose from. So that's why these are not in a number form. But me as the researcher, I could assign this a number too if I wanted to. So let me just add a new column to do that. I call it gender code, and let's say just female's the first one, so I'm going to make that a 1. I'm going to say agender or anything else that's a form of non-binary, not just male or female, I'm going to put a 3. And I can recode everything this way, etc. Okay, but whether or not I coded it as numbers or not, it's still the same type of data. It's still nominal. And you may notice that there are other nominal variables in this data set too. So we have race. People self-reported their race, and I gave them many different categories. And I don't have the list of categories in front of me of which number means which racial group, but I'm going to go out on a limb and say the majority here that I'm seeing, the number 7 probably codes for white or Caucasian. And then you have some people where they reported both, right? And that's totally fine because I'm not going to take an average of this number again. It's fine that people put 2 of them in here. That just puts them in a different category. We have a couple of other nominal variables here on the screen. We have country. Number 187, just from a long list of countries that were in alphabetical order, is the United States. And a lot of these others, I would have to go look up and see where they were on the list. But again, it wouldn't make sense to take an average of countries, right? So this number is not a real number, it's nominal data. And similarly, US state is also nominal data. Education is a slightly different type of data, okay? We can talk about this one as another step up. So nominal data that we've been looking at, where we have our subject ID, gender, country, US state. On the other hand, education has levels to it. You can say that some educational degrees are higher than others. So it's not just that they're categories where they're kind of all seen as equal and none of them can be ranked above the other. Education, you can rank them. You could put them in order from lowest level of education, like didn't finish high school. There might be a 2 that means high school diploma, 3 that's like associate's degree, and building up and up as the numbers get bigger, it means a higher level of education. The gap between a 1 and a 2 or a 2 and a 3 or a 3 and a 4 is not actually the same. Having finished high school versus not having finished high school, that's the difference between a 2 and a 1. But let's say that the difference between a 2 and a 3 is finishing high school and getting an associate's degree is number 3. That's not the same distance. It's not the same amount above. It's not the same amount of time even. The difference between didn't complete high school and has a high school diploma is not even the same for every person, right? So each person who put a 1 of didn't finish high school, that might mean something different. 1 is a category that covers a lot of things. So the interesting thing about education here is that it is not nominal. It has the first thing that nominal data has, which is categories. There are categories. It looks like 1 through 6 here at least. So it's got these 6 categories, but what it also has is the ability to rank. Something can be considered above or below another one, but not always the same distance between levels. And so that type of data is called ordinal. When we can rank them, we can put them in order, so it's ordinal. What we're looking at here is a survey created by Bear et al. 2008 that I gave my participants. It's called the 5-Facet Mindfulness Questionnaire. And this is an example of a different type of data that we're about to look at. So it's a set of 39 questions, and there is a score of 1 to 5 that a participant could give for each item. Also notice that some are reverse scored, which we've talked about in a previous module. But what this is measuring is how mindful people are. Mindfulness is defined as paying attention in the present moment purposefully and non-judgmentally. So it's just being in the moment and kind of letting your thoughts go without getting super attached to them. This is a trait questionnaire, meaning that this measures how mindful you are generally, kind of as a personality trait, not in this exact moment that you take the questionnaire, but just in general. So there are questions like, when I'm walking, I deliberately notice the sensations of my body moving. When I take a shower or bath, I stay alert to the sensations of water on my body. I can easily put my beliefs, opinions, and expectations into words, etc. So what we're going to look at is data of where a lot of participants took this questionnaire. This is the same data set that we were just looking at with our nominal and ordinal data. So all these mindfulness items are these 5-Facet Mindfulness Questionnaire items that people took, all 39 of them. And you can see people put their answers on a scale of 1 to 5. I already fixed the reverse coded ones. This is a different type of data where we do have categories. We have categories of 1 to 5. Let's look back at our questionnaire to see what those mean again. These categories, 1 through 5, mean 1 means never or very rarely true for me, and 2 is rarely true, 3 is sometimes true, 4 is often true, and 5 is very often or always true. So these numbers do stand for words. They do stand for categories, like our nominal data. Plus, they have ranking ability. Very always or often true means more often true than just often true for me, right? Often true means that's true more of the time than sometimes true. They can be put in order. But we don't stop there. These are not ordinal data. They have one more component to them. And that is that the distance between 1 and 2 and 2 and 3 and 3 and 4 and 4 and 5 is the same. We can consider these interval data. So never and very often are pretty much parallel options. Sometimes is right in the middle, and the distance you would travel mentally from sometimes to often is the same as from rarely to sometimes, etc. So not only is this ranking data we can put in order, but the distance between them is equal, and that makes it interval data. Now, your textbook talks about how researchers argue about how these types of questionnaires are ordinal or interval. We are going to treat them as interval data in this class instead of getting too deep into that debate. So what we have with this mindfulness questionnaire, where people rated 1 through 4 on each of the items, is interval data. Something that interval data does not have is a true zero, meaning you can't have 0 of an amount of mindfulness. Everybody has a little bit of this personality trait, and we all have different amounts. But there's no true 0 that means you actually have none of that thing, okay? So let's say we got a total score of all 39 items on this mindfulness questionnaire. The way we do that is just add them all together. Add one person's score on the first item and the second one for all 39 of them, okay? And we gave them a total score. And what we also have in many questionnaires is subscales or subscores to them. So instead of having a single mindfulness score, you just add up some of these items answers and you get one piece or facet. It's a 5-facet mindfulness questionnaire. You get just one facet of mindfulness. So in this case, you get how well people observe their experiences, how richly they describe them, how aware they are of the actions they're doing, how non-judgmentally they're approaching their inner experience, and how non-reactive they are to their inner experience. These are all aspects of mindfulness that you try to do when you meditate, or some people are just naturally a little more mindful in their everyday lives. So let's say we added up the questionnaire items that were asking about the observing aspect of mindfulness, and this participant one here got a 20 on this. Now, because this is interval data that has no true zero, there are some types of math we can't do with this. We can do averages and stuff, and we can compare them. That's awesome. What we can't do is say, this person has 1.5 times as much description as they do observation. We can't compare them in a ratio way, okay? We can't say that participant one has double the observation compared to participant two's non-judgment. Even if they were within the same, we can't say participant three, we can't say participant two had half of the non-judgment as participant five here or whatever. So that is the limitation of interval data, okay? It has the same things as all the others we talked about so far. It's got categories that can be put in order. And these categories that can be put in order have equal intervals between them, but there is no true zero. But there is data that has true zero. So we're gonna look at some examples of that. Also, in this same data set, I measured a construct called misophonia, which is a condition where some people have pretty extreme distress when they hear certain noises. It's just a way that their brain is wired and they can't shut it off. One of the most common ones is eating noises. I don't know if you are one of these people or if you know other people who are like this, where you just go into kind of a murderous rage when you hear people chew. People eating their cereal at the breakfast table just drives you up the wall and you just cannot stand it. It makes you angry. It like hurts you. Some people are just sensitive to different sounds like this, and we don't know why. And researchers are still working on how to treat it. It's not officially classified as a disorder in the DSM or anything, but it is a condition that people with other DSM conditions like OCD and autism sometimes have. So what I have here is a list of triggers on the misophonia questionnaire, okay? And I asked participants on a scale of 0 to 4, where 0 is not at all, and 4 is the most intense reaction possible, how strongly do you have a negative reaction to these types of sounds? And the list of sounds is stuff like people eating, tapping noises, rustling sounds, nasal noises. So anybody like blowing their nose or something like that, throat noises, throat clearing, particular consonants or vowel sounds when people speak. Maybe you can't hear those hissing S's without it driving you up the wall. Environmental sounds, so it could be like air conditioner, birds, a dog barking in your neighbor's apartment. That's one I hear a lot. Thankfully, I don't have misophonia about this. And so participants could say, no, if they put a 0 here, that means literally I have no misophonia, like negative reaction to the sounds of people eating. If they put a 4, it's like, yes, I hate that sound. It makes me hurt, makes me want to hurt people. I hate it. And then there's shades in between that are kind of equal intervals, okay? So what this data has is it has categories, right? These numbers still represent concepts and words like not at all, or a little bit, or quite a bit, or somewhat, or a lot, right? So they represent words and concepts still. So it has what nominal data has. Numbers mean categories. It also has what ordinal data has, which is you can rank them. A 4 is definitely higher than a 0 here. They're not arbitrary. jersey numbers and stuff like that, it doesn't matter if one of the numbers is bigger than another, or license plate numbers or whatever. Here it matters. So it has that ranking ability that ordinal data has. It also has interval. The distance between a 1 and a 2 is the same as the distance between a 3 and a 4, between a 0 and a 1, etc. So that has what interval data has. But it also has one more special feature, which is our final data type. It has a true 0. The 0 on here isn't just one of the points on a scale. Like with our mindfulness questionnaire, that was interval data, right? The numbers were 1 to 5, but I could have scooted those back and made them 0 to 4, and the questionnaire would still mean the same thing. It would still be interval data because the 0 doesn't mean having 0 of that mindfulness quality. In the same way that a 0 degrees Fahrenheit or 0 degrees Celsius doesn't mean no temperature outside, right? 0 is just a number on the scale, and you can even have numbers below 0, and they just mean something else, a different measurement. Here, we have a true 0. Our 0, it's a beautiful 0. It actually means nothing. Just rest in that awareness of nothing for a moment, right? Okay, so this 0 means that rustling sounds do not set off any unusual reaction for me. I have 0 of that quality. So what that means is that we have ratio data that has all 4 of those cool features: categories, ranking, equal distance between ranked levels, and true 0. So ratio data has all of those, and it's called ratio data because we can do some of the math with it that I said we couldn't do with our interval data. If a person has a 2 here for nasal sounds, it's because they have double the reaction in nasal sounds as this participant who put a 1. This participant who put a 4 has double the reaction to nasal sounds compared to participant 1, what they put. Interestingly, I see a quick pattern here I've never noticed before. Not a lot of people are that bothered by consonants or particular vowel sounds. Speech sounds are maybe not as big a deal to folks with their as misophonia triggers. So it super makes sense to use averages of this data too, and they are much easier to compare than in other types of data. So ratio data is pretty cool. So in your survey responses that you create, you need to think about each question you ask people. What type is it? Does it have a true 0, etc.? If it's one where you let them just leave open responses, that's typically going to be nominal data,